In this video, we will show how to use the DivEnact tool to assign and deploy software at the edge in the eHealth use case scenario. The first step is templates, which are used by developers to create deployment plans from a predefined and frequently used template by providing a target condition and filling in some parameters. These parameters are filled in the next tab called variants. Using variants, we can instantiate a deployment from a template. For example, we can see that this variant will instantiate the corresponding template by passing the URL of a Genesis model as a parameter. After we instantiate a template using a variant and push it for deployment, it will appear as a new deployment in the next tab. So let's try this now and see if the new deployment will appear in the next tab. In this tab we can see the list of deployments and the devices to which each deployment has been applied. As we can see, there is only one deployment at the moment, which is applied to 6 devices, but when we refresh the page, the newly created deployment shows up. We can also see the list of affected devices for each deployment and check more details in the next tab. As you can see in the Devices tab, we can browse through existing devices, see the deployment plans and Docker containers that they're running. We can also see the device tags and reported properties and understand why DivEnact assigned a specific deployment plan based on its target condition. We can also see where the edge devices are deployed physically. We currently have a fleet of around 50 devices, but for testing purposes only several of them are online. We now proceed with a live demo and show how we design a deployment and push it to edge devices. In the bottom frame you can see a Raspberry Pi and an Arduino board, which we use to simulate telemedical gateways and alarm buttons. In this scenario we assume that the patient has plugged in an alarm button, which will send an emergency signal to a supervising nurse. But before this can work, it is required to deploy new software components on both the Arduino and the Raspberry Pi. To do so, we instantiate a template using a variant and push it for deployment. According to the target condition of this new deployment, it will be deployed to a device which reports the connected Arduino board. After we create and push the deployment, it appears in the list of deployments in the corresponding tab after a few seconds. However, it will not be applied to our Raspberry Pi board yet, because the Arduino board has not been plugged in. As you can see, the corresponding reported property of the Raspberry Pi is still off. Next, we plug in the Arduino and see that the Raspberry Pi updated its internal context. This will trigger the DivEnact tool to reevaluate newly reported context properties against the target conditions of existing deployments. Among several alternatives, DivEnact will apply the one with the higher priority, which in our case is the deployment that we just created in the previous step. We can see that our edge device is reporting a connected Arduino, and after some time we can refresh the page and see that the new deployment has actually been applied. This means that the Arduino board has been flashed with the corresponding alarm button firmware, while the Raspberry Pi is now running an application to communicate with the Arduino over the serial port. This so-called last mile deployment bundle is implemented using Genesis, to which we pass the corresponding model with an Arduino sketch. Now that we have both Arduino and Raspberry Pi updated with corresponding software, we can start using the new functionality. But first we need to enroll the newly added button and link it to a specific patient of the TELU system. To do so in a trustworthy and secure manner, we are using EVDN access control server. When we start the enrollment process, we receive a 6-digit code which we need to type in a browser on EVDN's access control portal. So this way we implement two-factor authentication and ensure that the alarm button is indeed physically owned by a specific patient. After we authorize the alarm button and complete the enrollment process, the alarm button is provisioned with an access token, which can be used to send context information in a trustworthy manner. In our case, the context information consists of only on and off events that we send to TELU's platform to indicate that there is an emergency situation at one of their patients. Our use case assumes that whenever there is such an emergency situation reported by the patient, the supervisor and nurse will be granted access to turn on the remote camera and see what's actually happening and assess the situation immediately. In non-critical situations, the access to a camera is usually restricted due to privacy concerns. In the previous step, we showed how new software is assigned and deployed to edge devices. We now look at how a device can roll back to a previous software version or a default configuration. This functionality is also implemented using tags and target conditions of deployments. In our case, we simply unplug the Arduino board. The Raspberry Pi shortly updates DivEnact about this. As we can see, the corresponding context property of the edge device changed from on to off. DivEnact will again re-evaluate newly reported properties against target conditions of existing deployments and apply the most relevant one. In our case, the Raspberry Pi rolls back to the previous default versions of its software.